the blog, VLandHope.weebly.com. And for Algebra 1, click the Algebra 1 tab, and we are on Unit 4. From here, scroll down. We're on Monday 3/16. It's everything I would like for you to complete today. I will have the quiz review. We're going to do a quiz tomorrow, but it will most likely be on a quizzes link. You will click download, and I would print this out and complete it. Okay? You can pause this video and go to the important parts as much as you want, but I am going to work through this problems on the quiz review so you can check your work as you go along as well. So, at this point, I would pause, print it out, so you could work, and then check your work as I go along. But, number 1. Ask for an example of exponential growth and exponential decay. Also, bear with me on the technology. I'm getting there. So remember, exponential growth is anything as we go from left to right. The output, the y's, get bigger and bigger and bigger and bigger and bigger. Okay, something like that would suffice. An example of exponential decay is just the opposite. As you reach from left to right, it's going to go down, decrease. So we could go here and shoot down. Okay, just getting that visual piece. Number 2 is asking you to graph the exponential function and the asymptote. So from here, we are going to create our table. And if you have a multi-view calculator or a calculator that gives you the tables, that's awesome. I put a link on my blog. If you're able to get one, it'll be very helpful for you through all of math. But there are also many apps out there that can help you get that. But when I do my table, and remember, you kind of have to move around until you find those normal values that will fit on the graph. So I'm going to start at -1 for my x. -1, 0, 1, 2. And I get 5, 3, 2, and 3/2. Don't freak out on those fractions. 3/2 is just 1.5. Okay? And that fraction just gets smaller and smaller and smaller. So as we graph this, -1, 5, 0, 1, 2, 3, 1, 2, and 2, 3/2, or 1.5. And we know this outside value helps us find that asymptote. So when we graph, it's going to be a nice smooth curve, which gets closer and closer and closer, but will never actually cross. Okay? So we know the asymptote is at this dotted line, y equals 1. Okay? My asymptote. So that's how we get the graph. Number 3, characteristics. I have domain. Remember, domain is always all real numbers, or you can see that as -infinity to +infinity. Range is going to be all my possible y values. Reading from bottom to top, so we're scanning. We start this asymptote and go up and up and up and up. So my asymptote is at -2, and it's going to go, my y values are going to go up and up and up and up to infinity. And remember that -2 has a parenthesis in the bracket because it will never actually hit -2. My zeros are also my x-intercepts, where it crosses the x-axis. I have 1, which is at 3, 0. stylus. This is not working too great. And then from here, we have a y-intercept that crosses the y-axis. That is going to be at 0, 2. Now, growth or decay. Basically, you need to ask yourself, is it going up and up and up as we read from left to right, or down and down and down, decreasing? This is decreasing as we read from left to right. It starts up top, goes down, so it is exponential. Decay, which means it's decreasing on the interval negative infinity to positive infinity, or it means it's decreasing everywhere. It never changes direction like our parabolas. Last part, we call this end behavior, remember? End behavior. Alright, so as x goes to negative infinity, which is to the left, my y is going up and up and up. So my y is going to approach infinity. As x goes to the right, or gets to positive infinity, my y value approaches something called the asymptote, which is at negative 2. Remember, 1's always going to go off to infinity or negative infinity, and 1's always going to be the asymptote for our end behaviors here. Okay, so there's page 1 for our quiz review. Again, pause as needed. Work through these problems, but I only have a limited amount of time I can be on, so